Okay, in the previous videos we talked about protons and neutrons, number 1 and number 2, right? Protons are positively charged, neutrons by their name is neutral, so there's no charge. They don't contribute charge to the atom, right? Electrons, on the other hand, contribute a negative charge to the atom. You do need to know that. Quick summary from before. The mass of an electron is about 1/2000th of a proton. In other words, you need 2,000 electrons to actually equal the mass of one proton. To make a long story short, the mass is so small from an electron that we are going to discount it. In other words, the mass is 0 essentially for the electron. All right, we're just not going to include it in any calculations. That's why whenever we do the atomic mass, we just add the protons plus the neutrons. All right. Now let's look at the charge. The charge of the neutron is 0. The charge of a proton is positive. I'm just going to call this +1. And the charge of an electron is -1. Right? Many elements you see, right? The elements in the periodic table assume that the net charge is 0. In other words, let's look at this example over here. Right? 1 proton, 1 AMU, because that's the mass. So we know there's 1 neutron. And since there's no, we always assume whenever we're getting an element from the periodic table, in this case, the total net charge is 0, unless otherwise stated. Always assume the net charge is 0 unless I tell you different. Well, if we have 1 proton here, which has 1 positive charge, and the neutron gives 0 charge, how do we make the total net charge equal to 0? Well, there must be an electron here, which is not shown. And that electron, there's 1 electron here. So now 1 proton plus 1 electron is equal to a net charge of 0. Now we're focusing strictly on the net charge. Right? Now, it is entirely possible, if we look at hydrogen, it is entirely possible that we saw case 1, right? Case 1, to have a hydrogen like this with a proton of 1 proton, right? With a mass, the mass is usually on top, right? So there's 1 AMU. And I'm not going to write this out. You're usually going to assume the mass is on top in the notation and the atomic number is in the bottom. So usually you'll see it more like this. Right? So in this case, there's 1 proton and 1 AMU. And from this calculation, you will get 0 neutrons. Right? And I always told you to assume that there is no net charge here. Notice there's no net charge on the right-hand corner, right? So if there's 1 proton, 0 neutrons, and there's no net charge, we can assume that we have 1 electron because I told you there's no net charge. So 1 negative charge plus 1 positive charge, this is a proton, right? Protons are positively charged, will give us a net charge of 0. And usually in chemistry, you don't have a 0 up here, right? It just doesn't, it shows that there's no net charge. It is entirely possible that you can see a hydrogen like this, right? In other words, we're going to have the same scenario here now. One proton, one AMU for the mass right over here, right? No neutrons. And how many electrons do you think we have? Right? Well, the net charge here is +1. Right? So how do we get a +1 net charge? Right? That's because there are 0 electrons here. Right? If you have no electrons and you just have one positive charge, right? Because one proton is a positive charge, then you have a net +1 charge. And this is actually another notation on how many biologists describe a proton. They show an H+ here, right? Because the H here on the left-hand side without a plus is still one proton plus one electron with a net charge of 0. A lot of biologists and organic chemists actually call this on the right over here, that I'm going to highlight for you in yellow. Oops. A lot of biologists call this, or more simply, you'll see this notation, they call this a proton. And that makes sense, right? Because if you look deep into it, it's a hydrogen atom. It's got one proton. It's got one atomic mass unit, right? Which is entirely made up of that proton. No neutrons. And it's got 0 electrons, right? Which gives it a +1 charge. So biologists just call an H+ a proton. Now, anytime you see an atom with a plus charge, right, or a minus charge, we call them ions. In this case, if it has a plus charge, we call it a cation. So cations, I like the little plus to help me remember what a cation is a positively charged ion. In other words, it's deficient in electrons, right? If you have fewer electrons, you're going to have a positive charge, and we call that a cation. Now, it's entirely possible, if we go in the periodic table, and we're going to talk, you're going to learn about this in chemistry, that many of these elements aspire to become one of these noble gases. I won't go deep into that, right? It is entirely possible, in fact, it is more common, you'll see on Earth. Let's look at chlorine, right? Chlorine, you will see chlorine a lot like this, negatively charged, right? So how many, based on this diagram, how many protons do we see? How many neutrons do you see? And how many electrons are there? Right, I want you to figure that out. Pause the video. Right. So if we go over there, the easiest thing you could do is say, oh, chlorine, 17 protons, because that dictates the element. So 17 protons. How many neutrons? Well, take the atomic mass, which is 35, subtract 17 from it, and we get 18, right? 18 neutrons, because we said before that the atomic mass which is 35, is equal to protons plus neutrons, right? So neutrons has to be 18 neutrons. And how many electrons do you think we have? Well, a good way to think about this is the net charge of, there's 17 positive charges, right? 17 protons, right? How do we get a net negative 1 charge? Well, we have to have one more electron than proton, right, to have a net negative 1 charge. So by definition, it's going to be 18 electrons. Does that make sense? Because what is positive 17 minus 18 is equal to negative 1, right? And it turns out this chlorine, when it's an ion, in other words, an ion just means if there's a charge on this atom. If it is an ion and it is negatively charged, we call it not a cation, but we call this an anion. You do need to know these terms. If you have a hard time with adding these sign numbers, please practice on it because you do need to know how to add and subtract sign numbers, right, in biology. And we'll talk more in the next video.